Would you like to talk to me, please, about the functions of the placenta?
Okay. The placenta is the way in which the fetus in the maternal body receives oxygen and also discards of waste products such as carbon dioxide. It also has, aside from gas exchange functions, immunological functions, specifically transferring IgG across the placenta to the fetus to build its immune system. And it's there to remove waste products from the fetus also.
Right. What factors would you know that would determine the substances that cross the placenta?
So the substances that cross the placenta, or the factors that determine that exchange, are the same factors that would be the factors that determine any crossing of any substance across a phospholipid bilayer. They would include the polarity of the molecule and the ionization of it, with more unionized substances crossing in an easier fashion. The lipid solubility will determine the speed of which these substances cross into the placenta, and the size, of course, of the molecule, so the molecular weight, with it being a smaller compound crossing faster, or sorry, crossing easier. The concentration gradient will be significant of a substance, with the concentration gradient determining how fast or how readily a substance will cross.
Would you know any mechanisms by which these substances will cross the placenta?
So usually they can be broken down into, I suppose, passive and active transport ways. Passively tends to be molecules that are sort of crossing by osmosis, mainly water, and then also active transport mechanisms which use the concentration gradient of sodium. So that's been set up by the sodium-potassium pump. So facilitated diffusion, secondary active transport, and it's also possible to cross by exocytosis or penocytosis, so enveloping of the compounds with some part of the phospholipid bilayer, and therefore shuttling compounds across.
Right. Could you describe the Bohr effect in relation to placenta gas transfer, or the double Bohr effect?
Okay, so starting with the Bohr effect, it is a phenomenon which refers to the ability of carbon dioxide to bind deoxygenated hemoglobin more readily than oxygenated hemoglobin, which facilitates oxygen unloading and carbon dioxide binding of hemoglobin in tissues where that's appropriate, such as the fetal tissues. The fetus will be able to take more oxygen on from the mother's blood, which is actually, compared to the circulation in the mother, quite deoxygenated, because of that effect. So the gas exchange is only possible because of it, from fetus to maternal system.
Is that the double Bohr effect itself?
Yeah, so I suppose in our lungs, or in an acidic tissue, for example, or when we're using a lot of oxygen, we would have more oxygen unloading and more carbon dioxide uptake in those tissues because of the oxyhemoglobin curve shifting to the right under these conditions. And in the fetus, that effect is even more significant because of the fetal hemoglobin taking on oxygen even more readily.
All right, that's fine. We'll move on to next questions.
Mhm.